Okay, so first of all, you should have your calculators already, and let's take a look at the first one. It shows you the graph of the exponential function, where y is equal to 2 to the x, and you're going to take a look at the inverse function. Well, first let's start with the original. So we turn the calculator on and clear out all the other stuff. Okay, so we're going to start with 2 to the x. Now, when we graph it, it of course looks like the graph that they have over here. That's not very interesting. What we need to do is we need to look at the table. You'll notice that x has both positive and negative values. Even though on the graph it doesn't show up, it actually keeps going all the way to the left. The numbers just keep getting lower and lower and lower. So, is there any limit on the domain?
0.
On the domain. X can be anything, right? So your x value is all real numbers. Or if you want to write it as an interval, you would write it as between negative infinity and positive infinity. Both of those statements are equivalent. And now let's take a look at the range. Now, you had said that there was a limit on the y values. If you look, y has to be greater than 0. So that's your range. Y has to be greater than 0. Y is never equal to 0. It's just greater than 0. Now, your inverse function is the log 2 of x. Now, what we can do is we can actually graph this using our change of base, which is going to be on top, the x or the 2. What's the base? 2. So the base goes up high or down low? Down low. Log 2 on the bottom, log x on the top, and this is what we're going to plug into our calculator to graph the inverse function. So we go, okay, log x over log 2, and then we graph. Now you'll notice this is kind of symmetric, isn't it? This is kind of a flip of this, right? Now, this one had a horizontal asymptote. This one's going to have a, what's the opposite of horizontal? Vertical asymptote. So, if you look at your table, notice how your log function gets an error at 0, right? So that tells you that my x values have to be greater than 0, right? So here our domain is greater than 0, and which is similar to our range, right? So what do you think our range is going to be? All real numbers. Correct. That's the basic idea of an inverse function, to switch things around. So we could also write it as between negative infinity to positive infinity. Now, the next 8 exercises are actually just, hi, do you remember your log rules? Now, what's the base? 2. The base in the exponential form is large, right? What was large becomes small. So what choices can we eliminate because they have the wrong base on the log? B and D, they have the wrong base, right? The base is 2. Here, the exponent is near. What was near becomes far. What is the only one where the exponent 3 is far from the base? C, which is the correct response. So the easiest way to remember it is what was near is far, and what was large was small. Yes? I just nodded my head yes, so as to not have it on video. Nonverbal communication, gotta love it. Alright, now, did they give us the base in number 3? What is the base that we do not see? 10. So, because we know the base is 10, what choices can we eliminate automatically? C and D. So we pretend for a moment that the base is 10. The exponent was near and it becomes far. So what is far from the base? And so in the exponential form, what is near to the base? Y, so you see how the correct response is A. For number 4, what is the operation between the terms? And so when you multiply the terms, what do you do to the logs? Add the logs. The only one where they are adding both logs is B. For number 5, what is the operation on the terms? Division. And what is the operation on the logs then? Subtraction. Correct response is C. What's wrong with D? Doesn't have a log for the second term. Now, do we see the exponent? The exponent becomes the multiplier. What is the only one where the exponent becomes a multiplier? B. The exponent becomes the multiplier, and in number 7, the multiplier becomes the exponent. So this is actually the log 5 of x plus 2 quantity squared. Now, that is not one of our choices, is it?
No.
You have to expand the binomial square, right? You have to do the extended distribution. What you actually have to do is you have to do x plus 2 times x plus 2. What's x times x? X squared. X times 2 is 2x, plus another 2x is how much? 4x. And what is 2 times 2? 4. So now what's the only choice that has the binomial expansion? A. Correct response was A. Here they gave you the values, yes? They gave you values for the logs. What is the operation between the terms? What is the operation between P and Q? Multiplication. Now, if we are multiplying P and Q, what are we doing to their logs? Adding. And we actually have values for the logs. The logs are 7 and 2. Now, please tell me that juniors and seniors and even one sophomore at Lehman High School can add 7 plus 2.
9.
There you go. All right. Let's take a look at the next page, which is a little bit more fun and tasty. Okay. In some respects, yes. Might be a couple of word problems similar to the ones on 9, but not many. You know, with the word problem, when in doubt, do what? Plug the function in. Alright, what is the base for 9? X. What is the exponent? 2. So x squared is equal to 64, right? Now at this point, congratulations, you just turned this into a problem that an Algebra 1 student can do. How do you cancel a square? Take the square root of both sides. And so x is equal to the square root of 64, which is 8. Even if you don't have your perfect squares committed to memory, you have a $120 graphing calculator that should be able to handle such a simple equation. Now, let's take a look at number 10. You notice the bases are the same. What is the operation between the logs? Subtraction. So what is the operation on the terms? Division. So you have x over 2 is your new term. You have the log 5 of that is equal to 3. What is the base? Do you see that the base is 5? What is the exponent? 3. So we now have that 5 to the third is equal to x over 2. Can we evaluate 5 to the third? I want each of you to do that. Use your calculators if you have to. 5 cubed. If you have not committed your perfect, or 5 to the third, 125 is equal to x over 2. So what do we need to do to get x by itself? Multiply by 2. So, even using the calculator, if we had to, although you should be able to do it in your head, x is equal to 250. Now, there are two ways to do number 11. I'm going to do it what I think is the easy way. Is 16 a power of 2? Yes, it is. Now, if we have to, we can figure out what it is. What's 2 times 2? Times 2 is 16, right? So how many 2's do we have? We have 1, 2, 3, 4. So this is 2 to the 4th, right? So this is the log 2 of 2 to the 4th. What happens between log 2 and base 2? They cancel, leaving us with just what? 4. So you have the log 2 of x plus 3 plus the constant 4 is equal to 7. 4 is a constant, yes? 4 is a like term with 7. What can we do with it then? We subtract 4 from both sides. And now we have log 2 of x plus 3 is equal to 3. What is our base? What is our exponent? 3. What is 2 to the 3rd? 2 to the 3rd is equal to x plus 3. We can use the calculator to evaluate 2 to the 3rd if we don't know it by memory. 2 to the 3rd is 8. And so 8 is equal to x plus 3. And so x is equal to 5, right? Number 12 is a little bit more fun. 220 is not an exact base of 7, is it? What is our base? 7. What is our exponent? X. And what is our term? 220. So we say the log 7 of 220 is equal to x. Use our change of base formula. Is the base going to be high or low? Low. So you have the log of 7 down below, and what is going on top? The log of what? 220. At this point, you use your calculator to evaluate and set round answers to the nearest thousandth. How many decimal places is that? 3. So we use our calculator. We say, okay, the log of 220 divided by the log of 7. .7717, so we round up or no? Yeah. Yes, so 2.772. That was fun. What do we do first here? Divide by 1500. Shouldn't need to use a calculator for that. The zeros cancel, and what's 30 divided by 15? 2. So we have 1.2 to the x is equal to 2. What's our base? And what is our term? So we have the log of 1.2 of 2 is equal to x. Once again, change of base. Base goes below. Term goes above. And you can evaluate that on the calculator. .8017, round up or round down? So 3.802. Last one is wicked fun. What do we cancel first? The 15, the 5, or the 2.71828? The 15. By what operation? So 40 minus 15 is 25. So 25 is equal to 5 times 2.71828 to the x. What do we cancel next? 5 by division.
So you couldn't add 15 to 5 and then divide it by 5?
No, because what comes first in the order of operations? Multiplication or addition? Correct. So 5 is equal to 2.71828 to the x. What's our base? 2 point and all that. What's our exponent? X, and our term is 5. So we're going to take the log of 2.71828 of 5, log base of that is equal to x, which means using our change of base formula, we have the log of 5 on top, and then the log of 2.71828 on bottom, right? And then that can be punched in on the calculator and should give you some decimal approximation, which I will leave to your devices later in the interest of time. For 15, your y1 is everything to the left of the inequality sign. Your y2 is the log of 16. Go on ahead and plug that into the calculator. The solution is best seen in the table. And then the log of 16 is a value. The log of 16 is a constant. So when we go to our table, the best place to start is -1, and I will show you why. Because you have this error. That's an asymptote. If you look at your table, what do you notice about all the values of y2? They're what? They're the same. So we'll just make this 1.20 all the way down. And then -1, 0, 1, 2, 3, 4, and 5. Notice how here we have an error. That's important. And then we have 1.20 where y is equal to 3. And then we have 1.07, 0.90, and 0.60, and 1.30, and 1.38. Now, before you all leave, let's finish just this one part. We are looking for where the y1 is less than or greater than. What is this inequality? Less than. Or equal to. Where are they equal? Where x is equal to 3, and everything before that until you get to the error. Where do you get to the error? So it is between -1 and 3. We'll get to the graph.
You wrote it down on the graph. On the table, we got
1.30, yes. All right, and so when you go for the graph, as you can see, you have an initial curve, and then you have a horizontal constant line at 1.2. So 1.2 is about there. And at -1, you have a vertical asymptote, and it's about there, and it just keeps going, and then there's your point of intersection, and there you go. Okay, let's take a look at the back. So they gave you the function. Now the first thing you ever want to do is you want to go on ahead, when they give you a function, you want to go on ahead and plug it into your calculator. So m is your y, you have 20 times 1.22, or sorry, 1.122 set to the power of x. And so it says that the loudness in decibels is related to variations in air pressure, which is measured in micropascals. The relationship is this, where m is the air pressure and d is the loudness. Air pressure is m. So, at a noise level of 54 decibels, how much air pressure does this generate in micropascals? So in this case, you are evaluating the function where x is equal to 54. So, you're being asked to find y where x is equal to 54. So the easy way to do this, you already have your function keyed in. You're going to go to your main computation screen and you are going to select variables. And you are going to evaluate the function where x is equal to 54. And there it is, 10014. Next one, it said the pressure generated by heavy traffic is about 10 times the micropascals of that generated in a noisy cafeteria. How many decibels would that be? Well, so what we would do is we would say, okay, we're going to take our previous answer from 16, we're going to multiply it by 10. So you have 100,140 is equal to 20 times 1.122 to the x. Now, the first thing we're going to do, I multiplied my previous answer by 10. Now I'm going to divide it by my coefficient 20. And so that gives me 5007 is equal to 1.122 to the x. Now, this means that in order to cancel my base, I take the log. So I've got the log 1.122 of 5007 is equal to x, which means I use my change of base and say that x is equal to the log of 5007 divided by the log of 1.122. So I'm going to take the common log of my previous answer and divide it by the common log of 1.122. And so x is equal to 74. Okay. Now, it said the pressure generated by a diesel freight train is about 10 times the micropascals of heavy traffic. What would that be? Well, your process is similar, and so what you would do is you would take, okay, your y is equal to 10014. You multiply that by 100, because you multiplied by 10 to get to 17 and 10 more to get to 18. And then you set that equal to 20 times 1.122 to the x. So once again, you divide by 20. So you have 1001400 divided by 20, 50070 is equal to 1.122 to the x. We're going to take the common log of both of these. So we have the log of 50070 is equal to the log of 1.122 to the x. X is therefore equal to the log of 50070 divided by the log of 1.122 So take the log of our previous answer, divided by the log of 1.122, and we get 94. So we get 94. And so we find that for every 10 times, our constants go up by 20. And that's it for the review. Good luck on your exam tomorrow. Thank you.